this video, we're going to be looking at writing rules for sequences. So for each problem, we're going to describe the pattern, write the next term, and write a rule for the nth term of the sequence. So with these, you're really just looking for patterns, and to come up with that rule, it can be a little bit tricky, but you just kind of need to play around with it until you find something that works. So looking at this first one, I have -1, -8, -27, and -64. And so something that I immediately noticed with this sequence is that all of these are cubes. In particular, I see that this first term is equal to -1 cubed. This next term is -2 cubed, and -3 cubed, and -4 cubed. And so that means that my next term is that a5 is equal to -5 cubed, which is equal to -125. And so that's my next term, and then it does say to write a rule for the nth term of the sequence. Well, I can see that the nth term is just going to be -n raised to the third power. And I can check that back into my sequence here, doing what we did in the first video. I see that a1 would be -1 cubed, which is equal to -1. That works. a2 would be -2 cubed, which is equal to -8, which checks out with what we have in our sequence. And so this would be a rule for the sequence. Okay, looking at this next one, I see I have 0, 2, 6, and then 12. And again, I'm looking for some patterns here. I can kind of look to see what I'm adding each time. And so I see that I add 2, I add 4, I add 6. So I'm not adding the same thing each time, but I notice that my second difference is the same. So since the second difference is the same, that kind of clues me in that this is going to be a quadratic function, my rule for it. But now I need to figure out what this pattern is. And something that I notice is that this first term is the same thing as 0 times 1. The next term is the same thing as 1 times 2. Third term is the same thing as 2 times 3. And then the fourth term is the same thing as 3 times 4. And so I see that kind of pattern is I'm starting with 0, the parentheses starts with 1, and then you go up each time. So it's 0, 1. And then on my 0, I go up 1 to become 1. The 1 goes up 1 to become 2, 2, 3, 3, 4. And so that would mean that the next term, a5, would be equal to 4 times 5, which is equal to 20. And now I need to write a rule for the nth term of the sequence. Well, the nth term is going to equal to, remember that n always starts at 1. In my parentheses here, I started at 1, so I'm going to have an n in there. To get 0, I have to subtract 1 from it. And so I need to subtract n minus 1. Or in other words, an is equal to n times n minus 1. And when I plug my numbers in, I see that this checks out and gets me my original sequence back. Okay, now let's look at 2 more. So number 3, I have 3, 5, 7, and 9. And so I see that I am going up by 2 each time. Now, since the first difference is constant, that kind of clues me in that this is going to be a linear function, and that 2 is my slope. And so that means that I'm multiplying by 2 each time on my n. And so if I do 2 times 1, I get 2. And to get to 3, I just need to add 1. So that first one would be equal to 2 times 1 plus 1. The next one would be 2 times 2 plus 1. That equals 5. 2 times 3 plus 1 equals 7. And 2 times 4 plus 1 is equal to 9. And so that means that my fifth term is going to equal to 2 times 5 plus 1, which is equal to 11. And so that means that a rule could be an is equal to 2n plus 1. Okay, looking at this last one, I have 3, 8, 15, 24. And looking, I see I'm adding 5, add 7, add 9. So it's not a linear function, but I see my second difference is the same, so this clues me in that it's going to be a quadratic function. And here I see that my first term is starting with a 3, and I can see that if I do 1 times 1 plus 2, that gets me 3. Then 2 times 2 plus 2, that gets me 8. 3 times 3 plus 2 gets me 15. Then 4 times 4 plus 2 gets me 24. And so that means that my fifth term is going to be 5 times 5 plus 2, which gets me 35. And so a rule for the sequence would be an is equal to n times n plus 2. So for some of these, it may just take some guessing and looking around to figure out what that exact pattern is to get your rule.